So I have a little bit of an introduction for Dr. Bae here. So Dr. Bae is an assistant professor in mechanical engineering, engineering mechanics, and the College of Computing at Michigan Tech. She earned her PhD in mechanical engineering at Texas A&M University and worked as a research professor at Korea University before joining Michigan Tech. Her research interests include coordination of heterogeneous robot teams, vehicle routing problems, multi-agent system optimization, and autonomous vehicles. So it's a pleasure having you. Did you want to add anything to that I missed?
No, yeah, that's
Okay.
fine. Yeah, I'm going
Yeah.
to talk about my research, so that will introduce me as well. So okay, so it's a pleasure to have a chance to introduce about my research and then teaching through this meeting. So I'm going to talk about my research interest and then what's going on right now, and then talk about a teaching side a little bit. So my research interest lies on the autonomous navigation, not restricted to the ground robots, but including all the a different kind of autonomy in the aerial vehicle and then water vehicles. So I do study what will be the a chance to improve autonomy of those autonomous vehicles. So these are the projects that I was involved in before I joined Michigan Tech, and yeah, mostly about mobile robots, delivering the food or the fruit to the its destination. So other than autonomy, my research focus is actually lies on the heterogeneous robot coordination. So currently, most of the a warehouse or manufacturing or many applications that uses multiple autonomous vehicle uses all the same vehicles at the same time. But as autonomy is advancing so fast, it's not realistic to use all the identical robots at the same time. So my research more focused on the coordination of the heterogeneous robots. The robot has a different functions or different capability. We want to manage these robots in a more efficient way, and my research focused on that part. So we're trying to find the lower computational load algorithms that can manage the things in a good way. So that's the research side, and I just want to briefly introduce about my teaching interests. So this is the course that I have developed and then launched for the first time this semester. So the course is Autonomous Systems, and I'm planning to offer a similar kind of course in Applied Computing department, more focused on the computing side. So within this course, students learn about the basics about autonomy. So kinematics, perception, sensor fusion, path planning, localization, all that needs to know to actually work on the minimal autonomy on the robot. So not only restrict to the actual robot, students both work on the virtual and actual settings, and students learn computing side a lot through this course. So this one uses an open source platform called ROS, Robot Operating System, and partial codes are developed by the students and combined with the existing codes, and then we actually mount that algorithm to the real robot and test how it performs. So every week students develop their own algorithm, and then at the end of the semester students participate in the final project, which will be the competition. So integrating all the techniques together, and then accomplish the missions that is given to the robot. So that's like the fun course. And the other course that I'm teaching at Applied Computing is the EET course, LabVIEW for data acquisition. So in this course, students learn how to program like a graphical programming using LabVIEW. And students learn like how to take the measurement from hardware and then acquire the data with electric signal, and then how to actually use that signal like to control the like actual hardware. So LabVIEW will translate that electrical signal into actual measurement based on its code. And then students learn about both coding and then hardware side so that they can actually implement the learned things onto the real system. So other than LabVIEW and for DAQ, I also teach optimization course in the graduate level. So that's like the basic mathematical approach for the system optimization. And then I also plan to teach dynamic systems in mechanical engineering that deals with the like advanced dynamics and the little bit of the control side. So my teaching is mostly focused on the robotics, but not only restricted to the robotics, but also related to the measurement, coding, and both in the hardware and then software. So my presentation that's it. So I'm open to any questions. Denise,
Thank you, Dr. Bae. That was really interesting. Did our guests have any questions that they wanted to ask? So I have, I hope I'm not saying this wrong, Yakov, is that correct?
Yakov.
Hi,
Yakov?
how are you?
Oh, sorry?
How are you?
Oh, I'm fine. Fine. How are you? Yeah.
Good.
So I don't have any specific questions at the moment, but I just want to thanks for the presentation. Yeah, it's very nice. So the thing is, I don't really know very much about robotics, so it's nice as an introduction. So it's, maybe just a very general question: do you use any specific algorithms in design, in robot design? So something about motion planning, or?
Yeah. So for me, like I'm more like a focus on the optimization algorithms. So my most like a preferred algorithm is like a primal dual. So just like a mathematically like a formulated problem, and then just like trying to develop the like some of the approximation algorithms. But usually it ends with the heuristic, so hard to get the approximation ratio. But yeah.
So it's more about some geometric optimization problems?
Mm-hmm. Mm-hmm.
Ah, interesting. Is it related, I don't know, by any chance to art gallery? Art gallery problem? Do you?
So it's more about the like a traveling salesman problem.
Oh, it's more about travel. I see.
Yeah.
But geometric travel salesman.
Mm-hmm. Mm-hmm.
So probably, I think Euclidean traveling salesman.
Yeah. So like we have like just like a multiple like travelers, and then like sometimes it becomes like a postman like a problem, and then like
a traveling salesman, but with multiple travelers.
Yeah.
With multiple.
Mm-hmm.
With multiple salesmen. Ah, I see.
Yeah. So so I took like lots of like a CS course in during my PhD, and then so it's a lot related.
And I'm just curious, do you actually use any of the approximation algorithms, or you just use heuristics more like?
So I also like so I like I try to develop like an approximation algorithm. So like the like a goal is actually like a deriving the approximation ratio, but usually like it's really difficult to derive the like a approximation ratio. So end up with just like a presenting as a like a just a heuristic.
I see.
Yeah, but ultimate goal is like a deriving the approximation ratio. So for some algorithms, I have succeeded, but for some, just like I ended up with a heuristic.
Yeah, I see. Thanks.
John,
Mhm.
are you work on the hardware or you work on the software part?
So mostly I focus on software part, but
Okay.
like I also want to actually like confirm that the developed algorithm actually works on the hardware. So I do have like a lab for the like a experiment, and then I do have several like mini robots and also like pretty decent size of robots. So trying to like mix up the like agents together and then like try to actually like test the algorithm on the real robots.
Okay. Do you have some experience of the unmanned vehicle research?
IoT?
You for example, for the drones, drones. Do you
Oh,
have?
drones.
Yeah.
Oh, yeah. Actual one, actually no. And
Okay.
but like MK is actually my husband, and then he's working together with me. He
Okay.
has like experience in drones, so I can connect him with you if you need anyone like working on the
Okay.
drone side. Yeah.
Is he in Michigan Tech?
Yeah. He's a
Who?
research professor at like a mechanical engineering.
Okay. Because I plan to do some research 4 years ago. I have one Jones. I just want to, if some people can work on some hardware on the Jones, that should be good, you know. That's
Oh, yeah.
I'm looking for, you know.
Oh, yeah. He has like developed like algorithms like with the drones. So
Okay.
yeah.
Could you
I
yeah,
can connect
try,
you with
okay,
him. Yeah.
send him his email to me, okay?
Okay, sure.
Okay, thank you.
Mhm.
Any other questions? Well, thank you so much, Dr. Bae, for coming. And I really enjoyed your presentation and appreciated you taking this time. I really do. Thank you. It was nice to see everyone. Christy, thank you too for being here. I know you're taking time out of your day too. Okay. See you guys.
Thank you so much for coming.
One question. What's 1010 means?
Oh, 1010.
Yeah, what that does mean?
I think it's supposed to be, Christy, I don't remember, like 10 minutes, right?
It's the number
Okay.
10 in
10 minutes, yeah.
Coding.
binary.
Yeah.
Okay.
Yep.
Okay. That's good. Okay.
All right. Well, thank you, everyone, and have a wonderful evening.
Okay.
Yeah,
Thank
you
you
too.
guys.
Bye.
Nice to
Take
meet
care.
you. Okay. See you.